Hello everyone, welcome back to my channel. So in this video we'll solve problems regarding ADC and DAC. Okay, so I have discussed all the formulas and some of the important terms in the previous video. If you have not seen that video, please see there and learn the formulas, and then you can solve the problems which I am discussing now in this video. Okay. So in this problem, the first problem, he has given that the output range is 0 to 10 volts and you are asked to find the output V0 whose input binary number is 10 for 2-bit BDAC and 0110 for 4-bit DAC, and this for 8-bit DAC. Okay, so generally what is the, for the first problem A, what is V0 formula? VR, okay, VR or VFS, we will take it as VFS into D1 to the power D1 into to the power of -1 plus D2 into to the power of -2. Okay, where D1 is your MSB bit and D2 is LSB bit, since you have only 2 bits in this case. So V0 is equal to, what is VFS? VFS is equal to 10 volts, right? So 10 into, sorry, D1 is 1, so 1 into 2 power -1 plus 0 into 2 power -2. So it will be 10 by 2, which is equal to 5 volts, right? Similarly for the second problem, since it is 4-bit, so V0 is equal to VFS into D1 to the power of -1 plus D2 to the power of -2 plus D3 to the power of -3 plus D4 to the power of -4, where D1 is equal to 0, D2 is equal to 1, D3 is equal to 1 and D4 is equal to 0. Just substituting that, what will get? 10 into D1 in, so 0 into to the power of -1 plus 1 into to the power of -2 plus 1 into to the power of -3 plus 0 into to the power of -4. So 10 into, this will be 1 by 4 plus 1 by 8. So if you solve, you'll get 3.75 volts. Okay. So last problem, V0 is equal to, so in this case 8-bit, so D1 to the power of -1 plus D2 to the power of -2 plus D3 to the power of -3 plus D4 to the power of -4 plus D5 to the power of -5 plus D6 to the power of -6 plus D7 to the power of -7 plus D8 to the power of -8. So VFS is given by 10 volts, 10 into D1 is 1, so 1 into 10 to the power of -1 plus 0 into to the power of -2 plus 1 into to the power of -3 plus 1 into 2 to the power of -4 plus 1 into 2 to the power of -5 plus 1 into 2 to the power of -6 plus 0 into 2 to the power of -7 plus 0 into 2 to the power of -8. Just solve using calc, so you'll get around 7.34 volts. Okay, so this is how we can find the output if a digital data is given and your full scale rating is given. Okay, so in this problem, in the second problem, he has asked to find the values of LSB voltage, MSB voltage and full scale output for an 8-bit DAC whose full scale range is 0 to 10 volts. So we know that LSB voltage is given by full scale output by 2 to the power of n. So it is 10 volts divided by 2 to the power of 8. So it is around 39 millivolts. You just check it out using your calc. Similarly, MSB voltage is equal to full scale voltage divided by 2. So 10 volts divided by 2 power 1, of course, 2, which is equal to 5 volts. Similarly, full scale output voltage, full scale output is equal to full scale voltage minus LSB voltage. So which is given by 10 volts minus 39 millivolts, so it will be around volts, 9.961 volts. Okay, so all these formulas I have discussed in the previous video. Just see there and solve the problems in this video. Okay, so the next question, so he has given an 8-bit DAC with resolution of 20 millivolts per LSB. Okay, and you are asked to find full scale voltage and output voltage for digital data of this. Okay, so what is the formula for resolution? So resolution is equal to VFS by 2 power n minus 1. Okay, so resolution has given as 20 millivolts, okay, for LSB of course, is equal to VFS by 2 power n is 8 because it is 8-bit DAC. So this, so VFS is equal to 2 power 8 minus 1 into 20 millivolts. So if you solve it, you will get around 5.1 volts. Okay, so for the digital data, what is the output voltage? So output voltage in terms of resolution for a given digital input is given by resolution into D. Okay, so where D is the digital equivalent, decimal equivalent of given digital input. Okay, that means you have to convert the given digital input or binary value into corresponding decimal. So it will be, so D is equal to 2 power 8, 2 power 0, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. 2 power 7 which is equal to 128. So D is equal to 128. Therefore V0 is equal to, resolution is given as 20 millivolts into 128. Okay, so if you do that, you will get around 2.56 volts. V0 is equal to 2.56 volts. So always remember, V0 is the output of particular digital value and VFS is the maximum output voltage. Okay, so it is the maximum output voltage for a given DAC. Okay, so in the next problem, he has given that a 12-bit DAC has step size of 8 millivolts. Determine the full scale output voltage VFS and output voltage V0 for the input, this one. Okay, so he has given a sequence of binary numbers. Okay, so he has given n is equal to 12 and step size is equal to 8 millivolts. So step size is sometimes called as resolution also. Okay, so VFS is equal to step size into 2 power n minus 1, because resolution is equal to VFS by 2 power n minus 1. So VFS is equal to step size into this. So 8 millivolts into 2 power n is 12, 2 power 12 minus 1. So if you find, you'll get around 32.76 volts. So this is your full scale output voltage. Next, what we have to find is V0. So V0 is given by resolution into D. So D is decimal equivalent of the given binary number. Okay, so D, how can we find D? So the given number is 0 1 0 1 0 1 1 0 1 1 0 1. So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8 and 2 power 9. So D is equal to 1 into 2 power 9 plus 0 here, so we don't have to write it. 1 into 2 power 7 plus 1 into 2 power 6 plus 1 into 2 power 5 plus 1 into 2 power 3 plus 1 into 2 power 2 plus 1 into 2 power 0. Okay, so if you just calculate that, you will get around 1389. Okay, 1389. So therefore output voltage is equal to, resolution is 8 millivolts multiplied by 1389. So you'll get around 11.112 volts. So this is your V0. So the important point here is step size can be taken as resolution. Okay, if it is given in 8 millivolts, okay, so if it is given in volts or millivolts, you can take that step size as resolution. Okay.